Good morning and welcome. I'm Patrick Willoughby, instructor for this course. This is Organic Chemistry 1, and this is the first lecture. This first lecture is going to touch on a few introductory topics and really serves to warm you and I up to this mode of receiving our lecture content. I'm sure there's another video that describes the syllabus and how the course is going to sort of be structured and that sort of thing. This video is purely, and the other videos in the series are purely the lecture content. So without further ado, I'm going to quickly share my notes screen. There we go. Share. So we should be able to see the notes. So we're going to start with, I have a blank sheet of paper in front of me, and the first question we should ask ourselves when approaching this course is, what is organic chemistry? And so really to get at this question, it's we'll start simple. I mean, it's actually a fairly complicated answer, but we'll start simple and just leave it simple for a while, I guess. And it's the chemistry of things that have the element carbon. Now, this course is supposed to serve as a first chemistry course. So if you haven't had introductory chemistry at some level, whether that's college or high school, let's just kind of discuss what I mean by this element carbon. So carbon, as I said, is an element on the periodic table. Okay, and so it has the symbol C. We're going to be using C quite a bit in this course. Actually, after some time, we're going to further abbreviate the element carbon beyond the letter C. Okay, so that is sort of a starter definition. The chemistry of things that have the element carbon. We discussed what carbon was a little bit, but in this definition, I also used a fairly complicated word, a word I've been thinking about a lot for the past almost decade and a half of my life, and that is chemistry. So let's ask the question, what is chemistry? So chemistry is the study, or involves the study of the properties and composition of matter. Okay, the study of the properties and composition of matter. Okay, there's other words in here that I'm kind of interested in. Let's start with this word properties. Okay, so what is a property? If we keep it singular. Well, I like to think about properties as sort of being two types. We're going to have chemical and physical properties. I'm going to move on to another page. Okay, so chemical and physical properties. Just moving on to the next page, I'm going to start by, for some continuity, discussing first physical properties. These are, for a particular object, or really anything, measurable characteristics. It's a fairly broad definition when you think about it. Things that you can measure. So let's put that in here too. Things we can measure. Okay, so things we can measure, for example, let's throw up some examples here. We have length, mass, density, volume, color, size, luster, malleability. Okay, some of these are fairly clear. Like, how many times have you made an observation about an object's size? Probably frequently, probably constantly. We make observations about things' size. So that's really us assessing a physical property about an object or something. But other things could be more specifically, if we're thinking about size, on the topic of size, we could think about length, and we could think about volume. Those are two other ways to measure the size of something. Length being how long it is, volume being how much space it takes up. We can even have a ratio of those things, which is density, and we'll get into density in a second. Mass, that's another thing that's sort of related to the size of something. So when we think about mass, that's a measurement of how much matter is in something, but it really is quite proportional to how much it weighs. And there's some more complicated physical properties like malleability and luster, which are properties commonly attributed to metals. If you haven't seen those words before, don't worry. These are just examples of physical properties. And the point of seeing this list is that some physical properties are obvious. We see them all the time. Some are a little bit more, we may be a little bit less familiar with. Okay, so those are physical properties along with some examples. Let's talk next about chemical properties. So I'm going to try to answer the question. I didn't write the question, but I'm going to answer the question, what is a chemical property? And when we're looking at chemical properties, we're looking at how matter interacts. And interacts is a very good word, but chemists really like the word react. So how matter interacts or how matter reacts with other matter. So this is using the words matter. We keep this definition sufficiently vague, but the key the key word in this definition is interact or react. Okay, so when we're talking about chemical properties, we're talking about what types of chemical reactions something does. Okay, so what types of chemical reactions something does. Okay, so for example, e.g., we could be thinking about things lighting on fire. Those would be combustion reactions. And I'll frequently abbreviate the word reaction with RXN. If I put an S, then it's plural, reactions. Okay, so we have our chemical properties, how matter interacts or reacts with other types of matter. Okay, what kind of chemical reactions something will proceed by. So combustion reactions is, these are chemical reactions we've all probably heard of or are familiar with, just things lighting on fire. And we'll talk more about combustion reactions in upcoming lectures. The next thing I want to go on, move on to is the types of physical properties. I know I'm kind of bouncing back and forth, but I wanted to address both types of properties in general and then move into types of physical properties. So types of physical properties. It's good to see this. We may not use this so much in this class, but it's good to kind of discuss this. And so there are two major ways of categorizing or classifying physical properties. We could have intensive physical properties and extensive physical properties. Intensive and extensive physical properties. Okay, so let's define each of these and then we'll think about some examples of each. So intensive physical properties do not depend on the amount of stuff we're working with. Now, stuff is a nice word because it's something we can all grapple with, but a better word would be matter. So it doesn't depend on the amount of matter that we have, okay? The property, these are physical properties inherent to the matter that we're studying. Inherent to the stuff we're studying. Okay, so that's another way of thinking about intensive properties. These are properties that are inherent to the stuff that we have, the type of stuff. It may change whether you're looking at whether you're looking at maybe an iron type of matter or a gold type of matter. You'll see some things change. For example, let's look at some examples of this. We could look at color. Okay, for the most part, color doesn't seem to change with the amount of stuff. If you've got a few grams of orange powder and I give you a few more pounds of orange powder, it's still orange powder. You have more orange powder, but that didn't affect the color. Now, you might argue that, well, what about, I feel like if I add more of something, it could get darker. Well, that's more to do with opacity, and that's a different type of way of observing the way something interacts with light. So I'm just trying to keep it broader in our discussion of color. Another big one is density. Now, density we're going to get to in a second, but density is a really interesting one because it actually is inherent to the type of matter that we're looking at and doesn't change with the amount of matter that we have. So for example, the density, which is often written as this sort of rho of water, H2O, which I'm going to write water underneath it, and I should make this a bracket. Sorry, that's going to bug me. Now let's just do some colons here. Sorry about this. Okay, the density rho of water, which is also called H2O, is always 1. Okay, and that's, we'll add some units to that, grams per milliliter. Don't worry about the units too much. It's always 1 gram per milliliter, 1 gram divided by each milliliter. And then I'm going to add in here for the people that worry about this, at standard conditions, implying we don't have some crazy high temperature or some dramatically different pressure as we're typically used to working with. Okay, so my point is density is an example of an intensive property. Let's look at intensive physical property. Let's look at extensive physical properties now. Extensive, these are a little bit easier to kind of think about. Extensive physical properties, these do depend, i.e. they change. They do depend on the amount of matter or stuff we're working with. Okay, they do depend on the amount of matter / stuff that we're working with. I'm going to move the page. I suppose you can pause the video if you didn't get a chance to write that down. So sorry, I don't know how to make these have continuous pages. So moving on to the next page, again, we defined that extensive properties depend on the amount of stuff that we have. So what are some examples of extensive physical properties? Let's think back to that list that we had. Where we threw up several types of physical properties. What are some that actually depend on the amount of stuff that we have? So some that come to mind are the size-based ones. So if you have more stuff, you're going to increase the size of the collection of stuff or the type of matter that you have. So thinking about size-based things, let's pick on length. For example, if you've got I don't know, you've got a gold ingot and you add more gold ingots, you would say the length of your total collection of gold ingots is has increased, for example. And so length, volume, the amount of space that your stuff takes up, that's going to increase. So here we have things that don't necessarily depend on the type of matter that we have. Just if you're adding more stuff, you're going to increase or decrease these types of properties. So length and volume both increase as you add more stuff, so they are extensive. Okay, there's not a fixed length or a fixed volume of water. If you add more water, you're going to fill up your container more. Okay, so there's length, there's volume, and then there's mass. And if you haven't thought about mass too much, we can think about mass as weight at this stage in the game. So what's really interesting is mass and weight, or excuse me, mass and volume. You can actually take the ratio of those two, take mass divided by volume. That's actually the fundamental definition of density. If you take the mass of something and divide by its volume, you're going to get density. Now, we already defined that density is an intensive physical property, and mass and volume, we just said, are extensive physical properties. Okay, and this is kind of an interesting feature when you're thinking about defining properties as extensive and intensive. Oftentimes, intensive properties are some sort of ratio. That is, we take some typically extensive physical property and divide it by something to maybe set the size of that, of the amount of that extensive physical property in the numerator. So for another example would be when I said length, and I had a gold ingot, like a gold bar, and I said if you add another gold bar, the total length of your gold bars increases. You might be like, well, the length of each gold bar didn't change. Well, that's great. That's a great observation, because it reminds us that if we take length per or divided by one particular unit, that's a fixed property of, in this case, a gold ingot. Now, it could change based on how you're manufacturing the gold ingot. So I don't want to put it down here as an intensive physical property, but thinking about taking properties and dividing them by something, maybe another extensive physical property, or dividing it by a common unit, that's a really good thing to kind of pick up on. Okay, so we see that we can have a ratio of extensive physical properties to get to an intensive physical property. And that's really kind of a nice observation. And it reminds us that density at standard conditions is constant. / intensive, or inherent to the type of matter that we have. Density is constant no matter how much stuff we have. We can't force, again, under standard conditions, all right? If you change pressure and temperature, everything's out the window here, but the density is constant with the amount of stuff that you have. So if you started with some starting mass and you increase that mass, we know that mass is an extensive physical property. It changes with the amount of stuff that we have. If we take our mass and we increase it, we must simultaneously increase our volume, and it's the ratio, or taking mass divided by volume, that gets us our density. So even though we increase mass, shown here by this up arrow, and we would also have to increase volume. We can't increase mass without increasing volume under standard conditions, and as a result, our density is unchanged. Okay, I think that's a nice observation and a nice time to break for this first lecture. Okay, so I hope we enjoyed that. I'm going to do some troubleshooting, and hopefully the videos improve in quality, or if you really liked it, maintain in quality through the rest of the semester. Thanks so much.